We have nanosensing, we have nano-stealth technology, energy, nanomedicine, and also nanocomputing. And actually, there are many other areas that we can look at. So on slide 20, we are looking at the instruments of national policy. So when you look at national security, the national security of a nation must be maintained by the government. And how does the government do it? By these 4 tools of national security. You have your military tools, your political tools, your economic tools, and in the past 20 or 30 years, we now have our information technology tools. Now, these tools are used to leverage the power of the country to ensure that the enemies of that country cannot infiltrate the country and cause damage. So if we look at this, we can apply nanotechnology both to the military and information technology instruments of national power to exert the power, say, of the United States with nanotechnology. We can use it offensively, and we can also use it defensively. And if we look in the context of information technology, we can actually see that this would be an effective methodology for cybersecurity and information assurance, as well as waging cyber war through nanotechnology. So when you look at the levels of national defense and even national offense, there are 3 levels that you need to look at. The strategic level is the grand level of command and control of a nation. It uses all the instruments of national security, and purpose is to protect the nation, to protect the civil infrastructure, to protect the military-industrial complex, the energy sources, and all of the national infrastructure. Now, the operational level is where you have command and control of the nation's armed forces in a very specific region of the world for very specific purposes. Usually it's military purposes, but we can also exert other instruments of national power in the operational context. But you do fulfill your theater-specific execution through local commands. And then you have the tactical level. This is the level where we actually execute things. This is where military force is used, and this is where the tactical objectives of the country are enforced and carried out. So when we are looking at the tactical level, we are trying to neutralize the enemy in this region through physical or electronic means, and we're trying to seize control of the specific sector. The slide 22 is another concept that I want to cover. It's called the dimensions of the battlefield, or the old school, they used to call it the dimensions of the battle space. Initially, there were 3, force, space, and time, and now we've added information. So in order to obtain battlefield dominance, you have to dominate the battlefield through the use of force, the quickness of the use of force, the amount of space that you use, and the information that you have through intelligence, surveillance, and reconnaissance. So with slide 23, when we're looking at technology, revolutionary technology, no matter what type it is, you always start at the tactical level. And then over time, if that technology is viable and useful, it will expand to the operational and the strategic levels. So strong, viable technology will cause what we call a revolution in military affairs, which is essentially changing the way we conduct battle. Now, there are many examples of this throughout history: the use of a cannon, the use of gunpowder, the use of steam-driven battleships, the use of the airplane, submarines. It can even start out as tactical, like the German Blitzkrieg was a revolution. The Marine Corps amphibious assault tactics were revolutionary. Today, what's revolutionary is the use of drones is revolutionary, and what I foresee is the use of nanotechnology will bring about a revolution in military affairs. So what happens, let's look at drones for an example. When we first started using drones, drones have been around since the early 1900s. They were developed in conjunction with manned aviation, although they were very hard to control. We were using drones actually in World War I, we used them in World War II, and we used them extensively in the first Gulf War and the second Gulf War, and now in the War on Terror. So we started off using them at the tactical level. However, as they became prominent instruments of national security, we started using them at the operational level, and now we have entire military strategies that are based off of drone technology because they've become so pervasive and so innovative on the battlefield, because they have expanded force, space, time, and information together to improve our battlefield dominance. So drones have moved from the tactical level to the strategic level, and they've become basically a revolution in military affairs. Now, slide 24, all uses of technology will begin at the lower tactical levels, the local tactical levels. We'll be using test implementations of this technology in specific regions for a very specific national security purpose. Once we start using them, their use will be evaluated by the military-industrial complex, as well as related academic institutions. And of course, the initial uses of nanotechnology will be highly classified until initial studies are conducted and they're determined to be viable military instruments. And in most cases, the initial uses of nanotechnology will be used by special military operations, such as special forces teams. So in slide 25, you can see that effective use of nanotechnology must occur at the lower tactical levels, and they will only be useful if they improve one or more of the dimensions of the battlefield. If force, space, information, or time, if none of them are improved, then the technology will not be viable, will not be used. So the purpose of adding new technology is to increase force while decreasing space, while decreasing time, while increasing information. And if these things happen, the technology will be viable in the long term. And that's what we're looking at, long-term use. We can have experimental uses of technology, but if they don't improve the dimensions of the battle space, they will not be viable, and they will basically yield to other technologies that are coming down the road. For example, if we use drones to decrease sailor or soldier mortality rates on the battlefield, we're basically increasing our force while we're diminishing our mortality rate, which basically increases our force. So really revolutionary technologies such as nanotechnology, they must improve at least one or more of these battlefield dimensions at the tactical level to be viable and to be able to move into the operational or strategic domains. So let's look at slide 26. As the technology becomes perfected, it will be moving into higher levels of national security, and in fact may become the basis of national policy like drones are today. And at this point, the technology will become public. People will understand what it is and how it's being used as an instrument of national power. Other countries will have the technology, or will be trying to develop the technology, or will be trying to spy on countries that are using this technology in order to seize the intellectual property so that they can develop them themselves. At this point also, international bodies will become involved, such as the UN, because its use must be regulated. And if it moves all the way up through the operational to the strategic level, and we base parts of our national policy on the use of nanotechnology, we can consider this a revolution in military affairs by using this technology. It's for slides 27. So for current and future uses of nanotechnology, we can use quantum dots, actually right now, and they're basically tetherless sensors where we can monitor the enemy for ISR, intelligence, surveillance, and reconnaissance. We can use remote photographic motes for intelligence imaging, and all of these, the quantum dots and the remote sensors, can be networked in ad hoc computer networks, so that we can extend this range over large periods. Another issue is a cloak of invisibility, where we can coat objects or even people with nanomaterials, and these materials will actually deflect and disperse either light, microwave, infrared properties around the object, and that electromagnetic radiation will reform at the back of the object with little or no radiation absorption, which means the object may become partially or fully invisible. Now, this is a very huge technology, and I've seen it work on people with vests, and I see a very big potential for this. And then we also can have nanobiochemical devices where we're actually dispersing biochemical agents into an area as either weapons or antidotes against those weapons. Okay, slide 28. We can use quantum computing to significantly improve our military computation as well as weapon system precision. We can have cybersecurity and warfare computational improvements. We can improve battlefield energy distribution as well as battlefield communications. We can also improve medicine, diagnosis, and treatment in the battle space, but the counter to that, of course, is using bioweapons to actually cause disease and physical injury. Now, one of the bigger issues that we need to worry about is the use of nano weapons, large and small scale, where we can actually have nanobombs, nanothermite weapons, which can cause significant damage. Can measure it with nuclear devices if they are fully developed. And of course, we can have nano weapons of mass destruction, where we can have a very small amount of material that can cause significant damage. So slide 29, if we're going to use all of these types of nanotechnology in the military, we need to look at the ethical components of this, and we need to look at the ethics before we deploy a lot of these major technologies. And I have some issues of ethics listed here, and they're in no particular order. The first one would be environmental issues. We don't know how specific nanotechnology will react to the environment. Because we can have basically three types of nanomaterials: fully biological, hybrid, or those that are made out of material science. So do we know what's going to happen when we release them? Are they going to be chemically stable? Are they going to react with the ecosystem causing damage? And how extensive will that damage be? So we need to know all these things before we start using these. Now, national power. If these technologies become revolutionary, will they increase our national power? And this is dangerous because countries that have this technology may exploit that, especially if they have imperial expansion and dominance policies. So if you have a major weapon, you can use those for imperial purposes, like expanding your nation, expanding your influence in the world. So national power needs to remain in check if we use these type of military instruments. What about exploitation? Your country has bio, nano, quantum weapons, but what if they get into the wrong hands? And this is a very big issue, especially in today's world, where countries like Iran, what if they do get hold of these kind of technologies? And of course, you know, these nefarious sources that use these are not going to follow the Geneva Convention, so it's critical to keep this technology as close to the vest as possible. Now, slide 30, testing risk management. How much are we going to test? How much risk management are we going to study? How much risk will we assume? And should military lives be part of the military risk? What is the environmental risk? And what are the long-term effects of the technology? We must study this technology extensively. You know, we can't just test it a few times and then see what happens in the battlefield, because the stakes are just too high, especially with powerful technologies like this. Now, laws and regulations. We need to have laws and regulations in place before we start using this technology. Now, what are the societal impacts? What will be the physical and psychological impact that using these weapons will have on the society of the country that's using them? Will there be dissent in the population? What types of things are going to happen? Slide 31 is very critical. What is the impact on humanity? Will there be adverse impacts on the enemy population, both medical and physiological or psychological? And will this impact extend for many generations? Now, when we bombed Japan in World War II, subsequent generations still felt the effect through birth defects and psychological impact. So we need to look long-term at the effects on the enemy population. Will it impact world order? We have the use of nanotechnology and it becomes pervasive and very strong. Will this bring order or will this bring chaos? Will it separate the world once again into first, second, and third world countries? This is very critical. I mean, that's what happened when we developed nuclear technology. And also, what are the impacts on military personnel, since these are the people that are going to be deploying this technology? Will they suffer physical damage? Will they suffer psychological damage? And also the impact on society of the entire world, not just the enemy and the combat. We need to explore the entire effect worldwide of the use of these weapons. And also we need to think how nanotechnology relates to other sciences. Now, nanotechnology has very similar ethical questions as a process technology, as a biotechnology, as a chemistry, as a materials science. We need to know the differences that nanotechnology has from these different fields and what are the similarities. And then can these differences evolve into a new set of ethical platforms. So finally, my recommendation to the industry, to the military-industrial complex, to those studying strategy and policy, as well as the nation-states in general, is to develop ethical frameworks before you start implementing technology. Because ethical frameworks give you a guideline to help you form policies, strategies, laws, regulations, so that you can avoid long-term negative effects of the technology. And they must revolve around the use and the impact of the technology. They must, this is very critical, they must be human-centric and they must be environmentally centric. And they must also enforce proper risk management, technology testing, and evaluation. And they must be developed at the national level and encoded into laws, regulations, and policies before the technology is used. And they must have a method so that new discoveries can evolve into the law so that the laws are dynamic. And finally, nanotechnology is on the horizon. There is an abundance of research, and it will become a force in military operations as an instrument of national power. We just don't know how far in the future this will be, but I predict it's going to happen very, very soon. And I also believe it will cause a revolution in military affairs, especially if the technology is well developed, tested, and implemented, and if it improves the dimensions of the battle space, which I believe it will. We need to have extensive ethical frameworks that correspond to regulatory schemes and laws, both nationally at the nation-state level and internationally at the UN and Geneva levels. Because nanotechnology has the potential for mass destruction, so ethics is an absolute vital concern. Now, one more final point, I think this is a very critical point, is national strategy must drive the use of technology, never the other way around. Now, corporations and national policies sometimes do it the opposite way. Let's look at the dot-com era. The dot-com era, companies emerged and they founded their companies based off of the technology. So they let their technology drive their strategy. And what happened a few years later, we had the dot-com bust because there were no viable long-term business strategies that were developed by this country, or these companies. One exception was Amazon. Amazon had a very robust strategy, and the strategy drove its technology. And as of today, Amazon is now in one of the top 5 wealthiest companies on the planet. So it proves that strategy must be the driver of technology. So when we have national strategy and we use nanotechnology, we just can't implement nanotechnology for the sake of it. It must flow directly in support of our national strategy. And to conclude, Arthur C. Clarke formulated 3 laws of technological development. The first is when a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he is probably wrong. For example, Rand Corporation in the 1940s stated that there will probably be about 10 computers on the planet because they're too hard to manufacture. And now there are billions of computers. The second law, the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And this is how we extend our technology. And finally, any significant advanced technology is indistinguishable from magic. And nanotechnology may look like magic, but it will have lasting, long-term consequences, both for the United States and the countries of the world. So that concludes my presentation. So do we have any questions?